Hi everyone, Phoebe Nubisi here. Welcome to my channel. And in this video, we are going to see what is the difference between a fine-tuning a model, and building a model from scratch. Yes, you heard it right. Building a model from scratch is useful when you want to work with some time series data, some sales data to do some predictions, or maybe some purchase history, anything that has relationship with the past history of your data. And when you want to predict the future, that's where we come into place with um building from scratch. Yes, I will go straight on here. I have built two models. The first one helps to do a predictive maintenance on some sensors for some engines. Yes, and it uses some models like XGBoost. Yes, and then there is another one that we have built here that is helping us to predict on some what part we are going to need, some reorder points, stuff like that. This one we use Prophet and like GBM. Before jumping into all of that, let's go to some theory. Yes. For the theory, the comparison train from scratch and fine-tuning is that training from scratch, you start from nothing and then it can take hours to days. It uses tabular sensor sales data, history data, and then we have another type of approach for AI models that is called transfer learning. I'm learning this one too, and the starting point is that it uses some pre-trained model and then it takes from minutes to hours, typical use on images, audio, time series. And then we have the fine tuning that we all know that when we add an extra layer on a pre-trained large language model, so that we can use that to have a specific writing language or a specific type of output or a tone with your enterprise voice that you want. So we have those three. Yes. And then let's talk a little bit about training from scratch. Yes, you build a model with no prior knowledge. It starts completely blank and learns everything from your data set. You choose the model type, XGBoost, random forest, neural network, um, all of those. And you feed it your data and it figures out the patterns on its own. A real world analogy is when you have a fresh graduate or a new employee with no work experience on that field. They know nothing about your company yet, but you train them from day one using your own data, your own processes, your own history, and after training, they know exactly your situation and nothing else. Yes. So use it when you have some spreadsheet, record of sales, and to your specific domain for your company, and you want to have full control on predictions, on forecasting, stuff like that. And it's advisable not to have fewer than 50 rows of data. Yes, and no related pre-trained model to borrow from. Your data is text or images where pre-trained models already exist and are superior. Yes, so it uses for predictive maintenance, for example, that I showed you here, this one, this predictive maintenance, where we have a data set. I can show you how it looks like. Open a new tab. I believe it's the same one here. So this data set, it has many files with different conditions. The first file, it has one condition and some false modes, and the second data set has 6 conditions with one fault mode. Basically, it uses the output of sensor to give the the results. Yes, so we have some data like this coming from that. Yes, and we have also the testing part. Yeah, and these are the rules, so the conditions. So that's how it looks like. And this is a model. First, what it does is install the models like XGBoost and so on. And then once we install that, we now use this pandas to organize tables, NumPy to do math calculation on large data sets, operating system warnings, and with that, it grabs the column names of the units, cycles, operations, it grabs the data set from what we have here, and then it makes it available for us to use to see how it is. Train shape, we have in total 20,000 items, unique engines across 100 engines with sensors. So we have each unique ID with their cycles and their values per sensors. Yeah, so once we have that, we have another window. You can change to whatever suits your case, maybe 30 days or 48 days, 78 days or hours, up to you. And then here we have healthy, 15,000 rows, and then at risk 4,900, about 23%, imbalance 3-1. I need to know what that means too. So what we have next is the sample features. Features count 44 on that. And then we have the sample rows that we have tested, about 300 only. The total number of rows is 20,000, but we have just 300, and we have 228 healthy, 71 at risk, 220 we have 239 and 60 for validations. And then we have the result here. The model has been trained, we validate the result with the rest of the data, and this is what we have here. That's the result of it. 45 healthy at risk, 12, 13, and yeah, it's really interesting. It's here we have the top 20 most important features here, and yeah, we have the live engine status dashboard to see what what cycle, what sensor are in, or what engines are in critical phase right now. And then you have like engine 1, current cycle 31, failure probability 85%. So it predicts that it will fail, and the probability is 85%. So it's highly possible that it will occur. Yes, so it's critical. So it's very likely to fail in 48 cycles. Assign maintenance crew immediately. Same for the engine IT7. So you have some example. You ask me how did that got to this. I just asked Cloud Code to build me this based on the NASA dataset that I showed you here. And there we go. It uses, as you can see, it read just this one. Trying to see. It read just the first one, the first training, the one with one condition, the simple one, and because those are different conditions for different data sets. And that's how we got to this. Yes. So that's a predictive maintenance example. So you collect vibration and temperature sensor readings from your machine. You train an XGBoost classifier from 0 on those readings. The model learns what about to fail looks like from your specific machines. It has never seen any data before yours. Training takes seconds on a laptop. It doesn't take a lot of time. Now we have the next example, that is a demand forecasting example, where we have export about 2 years of all the history of an ERP system, and we train also again XGBoost regressor from scratch. This time we have used a different model that is called Prophet. I also asked Claude to generate that for me. So the model that we use here is the Facebook Prophet per pod, and it has been built in 2017, I believe, and it auto switched to a different model like GBM at scale for more than 2000 records. Yes, so our data set that we have is an online e-commerce data. Like you can see, it has the invoice number, stock code, description, quantity, invoice date, many other items. I want to see if I can click over so it shows everything. Apparently no, it's not able to. I wanted to see everything. Yes. So unit price, customer ID, country, and it has about the total of the file is a CSV file, 45 megabytes, and the number of rows we will see it in the code as well, and about 500,000 transactions, almost 3,900, so about 4,000 unique parts. And yes, so the output that we want with this demand forecasting is that it will tell us that order may be how many units of this part ID by next Thursday or by next week or this week, so that we will not run out of that part. Yes. For example, the reorder point that we work in this notebook is that the reorder point is like what is the amount of the unit of this part that we need to have. No matter how it is crazy at all time, we should have that. So that's what we calculate here too. I showed you the data set already. So here we will test on many amount of part. We will test for 50 part only, and then 100, 1,000. All of them we use Prophet, but when we switch to 10,000, that is more than 2,000, it will automatically switch to Light GBM. Yes, automatically. So I've run the first time. I've installed the libraries first. Yes, Prophet, Light GBM, Panda, of course, for the table organization. I talk more about them here. Pandas, what is Panda? It's a data library. It reads, it cleans, organizes tables of data. Simple as that. So you can load your CSV files and filter rows, compute some stats. NumPy is a math library that does fast math on large lists of numbers. And then Prophet is a forecast model. You predict the future demand using trend and seasonality. And then we have like GPM, that is an ML model that learns pattern from many features at once very fast. For example, it can do demand forecasting for more than 10,000 parts to 100,000 parts. And then we have XGBoost, that is also ML model, same idea as like GBM, slightly different algorithm. It also does predictive and classify healthy versus failing. We have Sarima, that is a stat model. So what it does is a classic formula for time series with strong seasonality. I believe I will do some project with that too. Single product forecasting, very interpretable. And then we have LSTM, deep learning for neural network that learn from very long sequences. Use it only when you have years of high frequency data. And then the combination of Prophet and XGBoost, when Prophet handles trend and season, XGBoost handles multi-part. Yeah, it's like a best of both worlds. So if you need this document, give me your email and I will send it to you. For example, that's more detail on Prophet. It has been built by Facebook Meta in 2017. and it's designed specifically for business time series data that has strong weekly and yearly patterns, exactly like retail's orders, manufacturing demand, or website traffic. Why have I become to be interested in this? Because I have worked previously in a manufacturing company environment where there were a lot of history of purchase orders, and it was a question to know at a given time what was the reordering point automatically for all the parts when you have 100,000 of parts at all time. How can you know that? So it was not possible. And also we needed to know at all time what is the mean and what is the maximum to forecast it, and so that we do not run out of part. And at all time we needed also to know what is the vendor that we use a lot for parts. For example, for part A, what is the vendor that we use a lot for it, and what's the pricing? Is it possible to switch to another vendor? Is it overpriced or is it the price good? How is the trend? Like next year, about this time, how can we budget so that we will be able to have all those parts on time and stuff like that? So it was all about prediction, and honestly I was really stuck because using the power platforms, I was not able to use the power platform for that. It was limited. Building like agents with Copilot Studio is not the same things. Those ones are like agentic AI, where you have an orchestrator that chooses a tool that acts, and then you monitor, you observe, and you take the next decision until you have the answer to your to the problem or to the user request. So this one is completely different, and I had tried to use power platforms, the models that they have. I can open it to show you what that means. It was also so limited as well because they had some kind of predictive. I will show you right now. So if I go to AI models, and then you will see some kind of predict future. This one is a custom model that it says that is built on historical data. It's not powerful because I tried to use it. It had given me such a hard time, and I was not really satisfied with it. So inclining to this part when, let me see if I have the other history. Yeah, so this one you will just follow the prompt, and then you run the model, but it's static and really it's not really flexible like what we want to do. So doing this right now, what I'm presenting to you guys is powerful because it's flexible. You use your own data set, you use AI to build the notebook for you, and everything is on point. Yeah. So for example, the prophet, it decomposes your time series in three-part trends. Is demand going up or going down over long term? It also check the seasonality. Does it repeat weekly, yearly? And then it check holidays, event. Are there one-off spike or drop? You see how sometimes when you have some orders, you can have like a peak of order by your customers, or it's like maybe 10,000 one time, but it does not repeat all the time. So do you have that peak maybe two times a year, or did it happen just one? And then based on all those factors, Prophet helps to have that knowledge, and based on all those factors, you are able to decide how many unit do you really need, because it will tell you about the spike and all of those, and it has to influence your choice as well. Yeah. So all of this, so let's come back to our example. Oh my god, it wants to switch off already. So when we come back here, for example, for this example, we have about, I showed you about more than 500k data set. But when we remove like returns or all the type of data that we don't really need, is about to clean up, because that's the purpose of this, to clean and reshape the daily demand. That's the goal of this one. So when it does that, we come back to 276,000 parts only transaction, and then it's about 3,900 unique parts, so almost the 4,000 that I showed you, and it's only in between 2010 and 2011, so about 1 year. And then the top 10 of part by total demand, we have this part ID, about 80,000 demand for that year. So that's the result that we have. And we have this other one where we say profit is at least 2 seasonal cycle. We set the minimum of 30 data days. So we downgrade even the numbers transaction, where we say we want the model to learn from the data that have transactions at least for 30 days. So if you have some part that have transaction for 8 days, 28 days, it's not enough for the model to learn from it. So we downgrade to have more data, so the model will learn from it for at least 30 days is considerable. So with that, we come back down from 3,900 to 2,400. So it has downgraded really low. So we have dropped about 1,400 parts. Same for the rows. We moved from 276k to 259k. So this next what it does, it tests now the part. So among those parts that we have filtered, again, we will test just 50 of them. So we will test many of them. We test 50. So for the 50 of them, the forecast date 28 days. How many days ahead to the forecast? So we want to forecast 28 days ahead. And then the lead time is between the time you order the part and the time that the vendor ship the part until it gets to you. So it's 7 days. So we assume that the lead time is 7 days. But you know that in real time, in manufacturing company or retail, those vendors, it will not always be 7. It will vary. So depending on vendors, it can be 2 weeks, it can be 7 days, it can be 1 month, it can be less. Yes. Now the safety stock says 95 service level. Yes, so the profit threshold is 2,000. Here is the threshold to switch from profit to light GBM for high large data set. We want it to be automatic. And then we have the function. Now we say part to forecast, we have 50 for now. Rows in the subset is about 11,000. So it has even downgraded more. And then the forecast horizon 28 days, lead time 7 days, the model profit. And then, yes. So now when we continue after doing and training the model on those 50 parts, while we have trained successfully, all of the 50 parts have been trained successfully, skip 0 of them. And then here is where we do the inventory decision and we simulate the current stock as a multiple of average daily demands. And yes, so in Clockle said in production, replace simulate stock with a column on your ERP CSV. So with this training data set, we have out of stock. None of them are out of stock. Critical 24, low 9, healthy 12, 5 overstock means that we have more than really needed. and then we have a dashboard that we have here that says that for the first part, for example, we have 5,000 right now in stock. In 28 days, the forecast is that we will need 16 more in the 28 days to come. But the real other point, like I mentioned, is the amount of part that we need at all time. No matter how crazy it is, we need that minimum. So it's about 28,000. So we need to order urgently about 23,000 units within the next 7 days, because that's the lead time. Yes. For the next one, we have in stock 342 units, and then the forecast say in 28 days we will need about 2,190 parts, and the reorder point is 1,356. So we need to order about 2,657 units within 7 days. Yeah. So these are just the results for that forecast. Yeah, it's like if you have your company data, you just put them in that in this dimension, country, customer ID, in this format, and then you can just rerun the script and you will have your answer in seconds, just like that. And we have some graphs here, and then this one help us to see that the reorder point for a part, for example, for this part 23,166, the average daily forecast is 0.6 per day, and then the lead time is 7, what we assumed for each vendor, and then the safety stock that we need is about 28,000, and it gives a reorder point about 28,000, and current stock we have about 5,000. So it says that the decision is about 23,000. But that safety stock, as you can see on this graph says that we had in, I believe, January a really high amount, but in June, July, August, when we see the trend, we did not really need that. So it was like a one time. So if we follow just that one time, we will need the reorder point to be about 28,000. So it's not really reasonable. So having those calculations, we still need to see this trend to say, hey, it's true that it says that we need 28,000, but in reality, we don't really need that much, because it was just like a one time thing, and it helps us to affine and refine our calculation and stuff like that. So basically that's what we have here. So I will rerun it to for the model for a thousand items. Here we did it for 50. So I will change it for 1,000 and run again. Says valid path is not defined. Auto switch. Let me start from the top again. Me restarting classes. This place should be the same, basically, because I have not changed anything. Yes, so the part to forecast is about 1,000, and the subset is about 153. It has really increased, and we are still using profit for that, because light GBM, yes, come after 2,000 or more. So it's training the profit for 1,000 parts. And it shows all the progress. One thing that is interesting with this is that, like, a couple months ago, I did not know that I could even do this, but it's so fantastic that I'm just doing it like it's something normal. So if I can do it, you can do it. So if you have any questions, ask me. I'm on my learning journey and we learn together. It's so amazing, this experience. And it helps you to see that if you have some real data, you just put it into a format that the model will understand and you just run it and it will work just like that. So this one, since it's 1,000, it's taking a little bit of time. It's just 30% for now. I guess it's been maybe a minute. I don't know. I haven't tracked the time, but I'm sure we can track the time. So it started at 20:25:12. 20:26. So it's about a minute already. All right, I think we are good here. It's 100% trained. Before we continue, there's something that I wanted to show you. If you check the settings, we made sure that internet is on, and on accelerator, we don't have any GPU enabled because based on my research, GPU is only served for deep learning when you want to fine-tune some large language models with those billions of data and stuff like that. Because, for example, Microsoft Phi, that model, when you download it, is already about almost 8 gigabyte in the RAM. So each time that you do maybe the training is 7 gigabyte. When you download for for the test evaluation is also 7 gigabytes, so it's really big. Or this GPU, they are only like 16 gigabyte on the RAM, so sometimes it's not even sufficient for that, so you have to remove the cache from that. I believe CUDA, that is also the GPU. You have to empty it before using it for evaluation, or when you want to compare the fine tuning of the model before the training or after the training. Each time you have to empty the cache, so you cannot have those two copies at the same time. But in this case, when we work for training a model from scratch, we don't download that model from Hugging Face or stuff like that. So here it runs on CPU and it's really faster. Like this one, we started like at 20, 26, 12, now 29. So it's about 4 minutes maximum. So it's very fast on 1,000 of parts. Training that model is very fast. So we train it from scratch. It's very speedy. That's what I wanted to let you know. Oh, it was 25, so about 5 minutes. Yeah. So it has trained about 5 minutes. I wish I could hide this. Let me see. No, it doesn't let me hide. I wanted to hide the output because it's too long. It's a bit long. But so we have finished the training now. So the result says all the 1,000 parts have trained successfully. Nothing has been skipped. So we move to the next to see what is overstock, what quantity is healthy, what quantity is out of stock, what quantity is low. All those details, we are getting it now. So we have nothing out of stock. We have 471 parts that is in critical. Some are overstock. Critical means that we are understock. Low means that we have to order them this month. Yeah. If I want to, if it's a real case, I can even ask Claude to give me a code where I can have the list of those parts, not just the quantity, the start, if that makes sense. So that is even the list here, the dashboard. we have some, see it says N 976 more. See exported CSV. I guess it has an output here. I don't see the output, but I believe we can export it and check the output. Let me see this. Yes. So we have like this first part. In stock, we have 318. Forecast that we need for the next 28 days that we need is 993. The reorder point is about 365 at all time. So we need to order about 792 units in the next 7 days because of this. And because of the reorder point too. And then we have this. It classifies the most urgent reorders right now. These are the most urgent ones. And we have an inventory dashboard, the stock versus the forecast demand. You want overstock is so little, low, we have so many, critical, they take all the place. Critical is you see it is about 47%. Basically, this one is the same response that we had before for the same part as well. I already explained that. And this is the same. It asks to order for the most requiring ones. So we will jump from 1,000 to 100,000. Let's see the result. I guess it would take maybe about 30 minutes. I wish there was a way to either hide this output or delete it. Oh, okay. It's gone. So let's change it to 100,000. It says only 2,400 parts available with enough history. Requested 100,000. So it will work with 2,400, and it has switched to light GBM. Now the training is ongoing. Oh, it's pretty fast. Because it started training it here, now it said light GBM is already trained, generating forecast per part. Wow, it went fast. It looks like it's faster than Prophet. Just to have more context to light GBM, let's call here again to read more about it. So light GBM is a Microsoft version of gradient boosting. It uses the same core idea as XGBoost sequential decision trees, but with a smarter algorithm that grows trees leaf by leaf instead of level by level. This makes it significantly faster and able to handle datasets with millions of rows and thousands of features, like this one that we are doing right now. It's pretty fast. Yeah. So light GBM and XGBoost are like two builders constructing the same house. XGBoost builds each floor completely before moving to the next. Light GBM builds wherever it sees the biggest gap first. Less work, same result, much faster. For a small house like 300 holes, you cannot tell the difference. For a skyscraper, light GBM finishes in minutes while XGBoost takes hours. Yeah, that's great. So it's about 5 to 10 times faster than XGBoost on large dataset, handles 100,000 parts in a single model, lower memory usage built by Microsoft, maintained actively used in production by Amazon, Alibaba, Uber, same accuracy as XGBoost on most problems. The weakness of it is that it can overfit very small dataset. Boost is safer there. Yeah. So use in the project, of course, that's the project where we use that. Now let's see XGBoost. I guess XGBoost is this one. It's a machine learning model that builds on a large number of decision trees in sequence, where each new tree corrects the mistake of the previous one. This process is called gradient boosting. It consistently wins data science competitions and is the most widely used model for tabular spreadsheet style data. Yes. Imagine 200 junior analysts each looking at your data and making a prediction. The first analyst makes some mistake, the second analyst focuses specially on the cases the first one got wrong, the third focuses on what the second missed. After 200 rounds, you average all their opinions. The combined answer is far more accurate than any single analyst could achieve alone. Yeah. So it learns which feature best predict the target. That's powerful. So it works extremely well on small data set, handles missing values automatically, does not need future scaling or normalization, twins in second to minute on CPU, no GPU needed, built-in feature importance tells you which inputs matter most, resistant to overfitting with tuning. Powerful. Let's go back to our model that we trained with light GBM. Is already done. Everything was done successfully. So now let's see the results. In this one, we have critical 75%. This is really bad. Low 250 and healthy 300 and overstock just 0.2%. And that's the result here for the demand forecasting. Oh, I see that one is taking very entire thing like this one. This same 23,166, about 25,000 reorder needed. It says the forecast chart is only generated on perfect runs. For light GBM runs, use the dashboard table in the exported CSV. It's very long. That's the dashboard. It's very, very long. Amount of part 100,000 per train 2434, light GBM 28 days, and those are the results. Alright guys, we had a good time. Let me know if you want us to do something more, but I hope you had fun like me, and see you in the next video. Ciao.